Hey guys, in this video I'm going to teach you how to solve compound inequalities. So these are inequalities that involve or and, okay? So I always call ands a sandwich because there's an X in the middle of two inequality signs. The or ones are always separated by the word or, so you know which type it is right away just by looking for that. All right, now when you go to solve these, you're still going to solve them the same way you would solve an inequality, but the or ones, you're going to have to solve two inequalities, and the and ones can be a little bit tricky because whatever you do to the middle, you have to do to the right and to the left as well. So your goal here is to get x by itself in the middle. So first, let's focus on the or side. So we'll do the or ones first. All right, so step one is to use inverse operations to solve each inequality separately for x. And then two, the graph is always two circles with the shading going opposite ways. So the trick that I always tell kids is the or ones, the graph looks like oars on a boat. So if you think about a boat, it always has two oars and they go in opposite directions. And you'll see what I mean when I go ahead and graph. All right, so oars are typically easier for students to complete because it's two separate inequalities and they look exactly like all the ones that we've been practicing. So I'm going to subtract the 7 first on this one. And I'm going to get 3x is less than 6. Then I'm going to divide by 3. The 3 is positive, so I don't flip the sign. And I'm going to get x is less than 2. I'm going to bring down that word or. Okay? And then I'm going to solve the right side. I'm going to start by adding 5. And then I'm going to get negative 2x is less than or equal to negative 6. I'm going to divide by negative 2. And since I'm dividing by negative 2, I got to flip that sign. So it becomes x is greater than 3. So first, this is my answer. X is less than 2 or x is greater than 3. So when I go to put these on the number line, you have to make sure that both the 2 and the 3 are on the number line. So this one's pretty easy because 2 and 3 are right next to each other. And then just fill in the rest of the number line. So 2, 3, 4, 5, 6, and 7. And then 2, 1, 0, negative 1, negative 2. Okay? Now, I'm going to have two graphs here, two lines, basically. X is less than 2 is one of them. There's no line underneath, so it's an open circle on 2. My x is on the left, so I can use the trick. The arrow points to the left, so I'm going to go left. But for my other one, again, open circle on 3. X is on the left, so it's pointing to the right, which means I can follow the trick. And there we go. So they are going in opposite direction. Oars will always look like this. They're like oars on a boat. And if you need me to demonstrate what that looks like, ask me in class. All right, let's try number 2. Same idea. Subtract the 7. So you get negative 2x is greater than 6. Oh, we really liked 2's and 6's apparently. Divide both sides by negative 2. Since I divided by a negative, you got to flip the sign. So x is less than negative 3. Bring down that word or. All right, add 5. I'm going to get 3x is greater than or equal to negative 6. Divide both sides by 3. Now, I want to point something out. The 6 here is negative, but the number that I'm dividing by is not. So since the number I'm dividing by is positive, the sign stays the same. X is greater than or equal to negative 2. All right, so this means x is less than negative 3 or x is greater than or equal to negative 2. All right, so when I go to graph, first of all, I need to make sure both of these numbers are on there. And again, they're right next to each other, so that's pretty easy to do. So negative 3, negative 2, negative 1, 0, 1, 2, and then go backwards, negative 3, negative 4, negative 5, negative 6, and negative 7. All right, the first one does not have a line underneath, so that's an open dot on negative 3. The arrow points to the left, so I shade to the left. This one does have a line underneath, so that's a closed dot on negative 2, shade to the right. Again, the arrows are going in opposite directions, so I know that I've done it right. All right, so I forgot to do this on the last problem, so we'll have to go back and do it, but we need to say a solution that works and one that doesn't. All right, so you have lots to choose from here when it comes to solutions that work. You could pick any number underneath this line or any number underneath this line. I'm just going to go with 0. That works good for me. But a solution that doesn't work is a little more tricky. You could choose -3 because this is open, or you can choose any number in between -2 and -3. So it could be -2.5, -2.6, any of those numbers would work. So I'm just going to go right in the middle and do -2.5. Now, if you go back up to problem number 1, where I skipped that part, a solution that works again would fall underneath here on either side. I'm going to pick 5. And a solution that doesn't work, you could pick 2 because this is open. You could pick 3 because it's open, or anything in between 2 and 3, like 2.5. That works as well. And that is how you solve and graph an OR compound inequality. So now let's talk about the AND ones. Again, I call these AND sandwiches because X is sandwiched in between 2 inequality signs. So your goal for this type is to get X by itself in the middle. So these will always look different than the ones that we've done previously. So you're looking to get X by itself in the middle. Again, the first thing I'm going to do is get rid of that constant, which is -4, but you have to do it in all 3 spots. So whatever you do in the middle, you have to do on the left and on the right. Keep that in mind. It's a little tricky. -2 minus 4 is -6, less than or equal to 2x, less than or equal to 10. Last step is to divide by 2 to get x by itself. That 2 that I'm dividing by is positive, so I'm not going to flip the signs. And I'm going to end up with -3 is less than or equal to x is less than or equal to 5. All right, so this time I need to make sure that -3 and 5 are both on my line, which can be a little difficult. Let's see if it fits this way. So -3, -2, -1, 0, 1, 2, 3, 4, and it just fits at 5 right there, and this is going to be -4. All right, so I'm going to have 2 circles, one at -3, one at 5, and they're both closed because both of these symbols have the line underneath. So a closed circle on -3 and a closed circle on 5. And these ones are actually easier to graph because they're always done like this. You always just connect in the middle. So it kind of ends up looking like a music note. Okay? All right, a solution that works is, again, any number underneath the line. I'm just going to pick 3. A number that doesn't work could be -4 because it's not underneath the line. All right, last one. Same idea. I want to get x by itself in the middle. I'm going to start by adding the 1. 3 plus 1 makes 4, less than -x, less than 6. All right, even though it's not there, there's an invisible 1 right here, and I'm going to divide by it because I need that x in the middle to be positive. So divide by -1 on all sides. Now, because I divided by a negative, these signs both flip. They both have to, not just one of them, but both of them. 4 divided by -1 is -4, and 6 divided by -1 is -6. Now keep in mind, this is backwards now, so -6 is smaller than -4. So I'm going to start by putting -6 here, -5, -4, -3, -2, -1, and 0. And then this way is -7, -8, and -9. Graphing this is exactly the same as the last one. I'm going to have an open circle on -4 because there's no line underneath the symbol. And I'm going to have an open circle on -6 because there's no line underneath the symbol. And I'm going to connect them in the middle. Again, the AND ones always look like this. You don't have to think about which way the line goes because it's always in the middle. All right, a solution that works would be -5. A solution that doesn't work would be -3. And that's it. All right, ORs on a boat if it's an OR, music note if it's an AND sandwich. Okay, that's it. That's how you solve and graph compound inequalities.